This is the Geometry 1 final review. So now going through this, it says BD, this piece right here, bisect. So bisect means, define bisect, cuts into two equal parts. Okay, so now if it's equal parts, I know that these two are going to be equal, so I go 2x plus 50 equals 5x plus 5 okay, let's go minus 2x minus 2x minus 5 minus 5. So on the left side over here I get 45 equals 3x divided by 3, so I get x is 45. X is 15. There we go. So x is 15, and now it says that it is trying to find measure of ABC, so that's going to be the whole thing right here, all of it together. So I need to plug it into both of it. 2 times 15 is 30, plus 50 is 80. 5 times 15 is 75, plus 5 is 80. And all of it together is going to be 160 degrees. Alright, for this next part, it says, use the picture at the right to answer the following questions. So, define parallel. We have coplanar lines that do not intersect. Okay, I'm going to do all of the define right now real quick. Intersecting lines, so perpendicular, interior, INTE, intersecting lines that form 90-degree angles. And for skew, non-coplanar lines that do not intersect. Okay, so now we got all those. Now we could actually go through and use these. So identify two segments that are parallel. There's so many on here that I could actually just pick any of them. And so if I pick this one right here, if I pick BF, I have so many that will be parallel. That'd be CG, DH, or EH. So there's more than one right answer. Lines, two line segments that are perpendicular, so they intersect forming a right angle. Let's say AE and EF. So these are, there's a lot of them on here. And so, again, there's so many that it's hard to actually just identify two of them. And now skew is a funny thing, so I'm going to actually use this one right here. So I'm going to, if I say EF, because skew is a weird definition, skew is not what it is, it's what it's not. So it cannot be parallel, so I'm going to get rid of that one, and that one. So none of those are going to work. It cannot intersect, so it cannot be that one, it cannot be that one, it cannot be that one, cannot be that one. So that means it's only going to give me this, 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 and this. So I have 4 lines that are skewed to my line EF. So any one of those will actually work to answer mine. So it's going to be A, D. Now for the next one, it says use a compass, construct a perpendicular bisector of the following segments, then list all your steps. Now, okay, on this one, I'm going to kind of cheat a little bit since I am recording this. So I'm going to just talk my way through this, and you guys are going to be able to write this down as I go over it. So first thing I'm going to do, I'm going to stab one of the points. I'm going to stab point B. So once I stab point B, I open it up more than halfway, so that's going to be right here. Draw my arc. There I go. And then I'm going to stab point A without changing the size. And I'm going to draw my arc. Right there. So I have that one now. And now from there, I need to go ahead and draw a straight line between those. Okay, let's see. I'm going to draw my line. So I'm going to make points where my arcs intersect. Draw a line there. Okay, right here, I'm going to call this one M. It's going to be my midpoint. So since this one is bisecting that, I know that this is going to be congruent to this, and it's perpendicular bisector, so it's going to create right angles there. So there's all your steps. So if you need to go back over it again to catch those, go ahead, pause it, and then back it up. Alright, so now for this one, it says AM is a perpendicular bisector of XY. So if it's a perpendicular bisector, a couple things I know. This is a right angle. This piece is congruent to this because AM is bisecting XY, so it's cutting this one into two equal parts. So I know that X plus 6 is going to be equal to 2x plus 3 minus x minus 3 minus 3. So on the left side over here, I get 3. Right side, I get x. So x is 3. So that makes this one 9. 6 plus 3 is 9. 4 times 3 is 12. And now from there, I have that this piece right here is a right triangle, and to find the missing side of the right triangle, that one's going to be my hypotenuse. So let's take a look. I'm going to have 9 squared plus 12 squared equals c squared. So c is going to be equal to the square root of, that's going to be 81 plus 144. So c is going to be square root of 225. So c is 15. So I get my value for xy is 15. Alright, for this one right here, now it says given, prove this right here. So now, first thing I'm going to do, right here, I always state my given, because that's what's given to me. Second one, this is actually a property of equality, because equal is the same as saying congruent. So now the next thing it's going to say A is equal to B, B is equal to C, then we could jump that A is equal to C. So if you remember from this one right here, so A to B, B to C, and then A is equal to C because they're both equal to B. That's my transitive. I-V-I-T-I-V-E property. Transitive property. And then this last one right here is going to be a property of congruence, because equal is the same as saying congruent. Define transitive property. So transitive property as a definition is going to be if A equals B and B equals C, then A equals C. Number 9 says QS is a perpendicular bisector of PR. So right here, I know those are congruent. That's going to be congruent to itself. So these are congruent triangles. So I know that this piece has to be congruent to that piece right there. So I know that 3n minus 1 is going to be equal to 5n minus 7 minus 3n minus 3n plus 7 plus 7. So on the left side I get 6, on the right side I get 2n, so n is equal to 3. And it says find QR, so QR is from here to here. So it's going to be 5 times 3 minus 7, which gives me 15 minus 7 is 8. Now on this next one right here, so I'm going to go item by item here. So 1 and 8. So 1's here, 8's here. So now they're dealing with these two parallel lines, so they're alternate sides. This one's my transversal, so alternate exterior. Alternate exterior angles. Now 1 and 5, they're both on the same side. This one's located on the inside, this one's located on the outside, so that's corresponding. Two and 8, 2's here, 8's here. Oh, I'm sorry, 2 and 11. So 2's here, 11's here. So 2 and 11, so they're talking about these two parallel lines now, and now this is the transversal. So those are on the inside, and they're on different sides. So that's alternate interior. 4 and 8, 4's here, 8's here. So inside, outside, same side, so it's corresponding. And 10 and 11. 10 and 11 right here, they're both are at the same vertex right here. So now together these make an X, so that makes them vertical angles. Alright, it says find the slope of each line, explain why lines A and B form a right angle. So now I have to pick points on there. So here's a point right here where they intersect at a good spot, so I could actually pick that one. I don't pick it halfway in between because I don't know what the coordinate would be right there. So I know this one and I know this one. So for line A, my slope is rise over run, so must rise 1, 2, 3, run 1, 3 over 1. And now for B, pick a point. Here's a good one, and here's a good one right here. So now my slope, it's going down. To show that I'm going down, that's a negative. It's going down 1 over 1, 2, 3. So down 1 over 3. So now because of that, it says explain why that they form a right angle. So given that what I have right there, that the slopes are opposite, and 1 second, make sure I spell it right. RECIPROCAL. The slopes are opposite reciprocal, so that makes it perpendicular, which is a right angle. So now for this next one here, I'm going to go ahead and take a look, and I'm going to draw A, B, C, D. So slope of AB is 2 over 3. 2 over 3. So that means that this one is 2 over 3. So if it is a rectangle, there's a couple things I need to know. I know that rectangles' opposite sides are equal. And I know that opposite sides are also parallel. And also, to go along with that rectangle, that there is going to be a right angle in each corner. So if the opposite sides are parallel, that means that CD has to also have the same slope, which is 2 over 3. And for this to be a right angle, they have to be perpendicular right here. So now for it to be perpendicular, they need to be opposite reciprocal, and that's going to give me a right angle right there. So opposite reciprocal, I'm going to flip it, and it's going to be opposite. So if I have 2 over 3, it's going to be a negative 3 over 2, and that would go the same for the other side. Alright, for this next part right here, we need to go through and write down all the information you need to prove the quadrilateral is going to be a parallelogram, rhombus, square, and rectangle. So I'm going to go through my list. Two pairs of parallel congruent sides. A rhombus has 4 congruent sides and diagonals. Are perpendicular. A square, 4 congruent sides. Diagonals are perpendicular, and for the rectangle, diagonals are congruent, and 2 pairs of parallel congruent sides. There we go. So now I have all the information I need for that. So I'm going to go through and have to find a whole bunch of information to go along with this. So these are what I'm using for this right here. So in a rectangle, I'm going to go through and I'm going to start finding. So whenever it says find the length, that means I have to find the distance. So EF. How far is it from 2 to 3? It's 1 squared, plus how far is it from 6 to 7? It's also 1 squared, so it's going to be the square root of 2. And I'm not going to approximate it yet because I really don't need that for what I'm doing here. I don't need the actual approximate answer for this. So next one's going to be FG. So how far is it from 3 to 6? It's 3. How far is it from 7 to 4? It's 3. So it's 9, square root of 18. GH, so that's 6 to 5 is 1. And 4 to 3 is also 1. Square root of 2. And the last one is going to be EH. So from 2 to 5 is 3. And from 6 to 3 is also 3. So that's going to give me 9 square root of 18. There, so given this information, I know that the opposite sides are going to be congruent, so I have that much information here. So I'm going to go through and categorize this, but just not yet, because I need to know the slopes of the sides first. So now for the next one, I'm going to find the slope of each one. Slopes for EF. So slope is going to be 7 minus 6 over 3 minus 2, which is going to give me 1 over 1, which is 1. FG. FG, so I have 4 minus 7 over 6 minus 3. So that's going to give me negative 3 over 3, which is negative 1. Next one's GH. So G to H, so it's 3 minus 4 over 5 minus 6. So that's going to give me a negative 1 over negative 1, which is 1. Last one is going to be EH. So it's going to be 3 minus 6 over 5 minus 2, which is a negative 3 over 3, which gives me a negative 1. So now, the information I have that I have opposite sides are congruent. I have parallel sides here and here, parallel sides here and here, and then they are going to be opposite reciprocal of each other. So if this is 1 over 1, the opposite is going to be, so for it to be perpendicular, sorry, put perpendicular here, be opposite negative 1 over 1, because it's 1 over 1, then flip it, so which would give me negative 1. So those are perpendicular, so that means I am going to have right angles, so that makes this a rectangle. Okay, for 14 it says, given the diagram at the right, find the slope of each side. So let's do RU, and I'm just going to use the graph to count. So it's rise over run, 1, 2, 3, 4, 5, 6, 7, 8 over 1. Next one's going to be RS. So RS is going to go 1, 2, so the rise is 2, over 1, 2, 3, 4, 5, 6, 7, 8, which gives me 1 over 4. When it reduces, the next one's going to be TS. TS. So the reason why I'm doing T first is because I always want to read it from left to right, because it's always overrun and the run's to the right, and that means that if I go up it's positive, if I go down it's negative. So let's take a look. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9 over 1. So I'll recount it to show you. 1, 2, 3, 4, 5, 6, 7, 8, 9 over 1. And my last one is going to be UT. So UT is going to be up 1 over 1, 2, 3, 4, 5, 6, 7, 8. So there we go. So which sides are parallel, if any? So let's take a look. None of them have the same slopes, so we'd say none, and okay, so do not have same slopes. So we know that parallel lines always have to have same slope.